When we were planning this panel, Daniel emailed about a month ago and said, are you guys planning on presenting work in progress or work that's really final, or like what stage? And everyone wrote back immediately, like, work that's really final, this is like really nice and polished, like I'm doing something I've been working on for a long time. And I don't know what I was thinking about that day, and then I like could have pulled out it and I didn't, but I was like, I'm gonna present this new work that I'm super excited about. This is the thing that like I get really psyched to work on every day, but it's like, preliminary is a very generous term for what this is. This is 3 related projects, each of which is like multi-pronged. And for some of them, I have results, you'll see at the end. And for some of them, I have like nascent thoughts about how one might collect data to look at these nascent questions. So you're gonna be seeing what I think is the most interesting stuff I'm working on these days, but be forewarned that you're not gonna necessarily come away with any clear findings, but you will hopefully come away with some enthusiasm for these potential questions. So this work is all kind of motivated by pictures like this. This is from Clemson, and this is the curricular map that they give their students for how to earn a degree in mechanical engineering. And this is what they put online to help students navigate their way to a degree. This one is way better than San Diego State's computer science degree, which like has no starting point, or it has a starting point and no finish point, right? And they like, and all these errors and stuff, and you're supposed to figure out how to get a degree in computer science. And this is what they put to help the otherwise like written requirements, right? So this is like, they're like, we're gonna really help our students figure out how to do this by putting these maps. So side note, this is work with Nick Huntington-Klein, who's at Cal State Fullerton in the econ department. And I sent him the presentation last week and I was like, here's what I'm gonna do. And he said, you can't put that picture in. That's a picture that I think they have up there about how to not make flow maps. Like this is an example of what not to do. Because he really thought that this was like something that someone had put up as like, this makes no sense, don't do this. But this is what San Diego State honestly puts up to help their students get a degree in computer science. A slightly better one comes from UMass Dartmouth, which is like very linear, right? These like nice kind of follow these arrows and you'll figure out where to go. But a couple of things I think from these maps. One, they're all from engineering, computer science. Not surprising, right? Like engineers and computer scientists like these kinds of things. So those are the departments that do it. You can't find these, and I have Googled extensively to try to find these for other departments. They don't exist. Second, these maps don't have a lot of choice, right? It's all about start here, take this, 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 and this, and then you'll graduate. But there's not a lot of like options, right? Like take one of these 6 classes, and then from this requirement, then take one of these 7 from here. It's all about these like very defined curricular maps. Another thing is that there's a lot of this kind of delay and blocking is what people call it, right? So if you look at this class here, to take, I don't even know what that stands for, CEN, something engineering, 491, you have to have passed this really long path of prereqs, right? So there are a lot of classes that have major delay factors. You can only take them after having taken a lot of other classes. And then other classes are big blockers, right? So Math 114, if you don't pass Math 114, you can't take about 75% of the remaining courses, right? So there, people have been talking about in engineering delays and blockers and stuff. But what Nick and I have been starting to realize is that these engineering course maps aren't really good ways to think about most majors. So if you, this is the UCLA bio course requirements to get a major in bio. And there are a bunch of things here that are really evident that you don't see in engineering. And why I'm picking on engineering is because that's the only discipline in which anyone has researched this question of how do you pick classes to graduate. And that's, and all they talk about is delay and blocking and these course paths. But I think there's a lot more complexity that's not represented in those course maps, which is what we're gonna get at today. So in bio, right, there are these 5 different categories that you have to fulfill, and there's tons of choice within that. There are 150 different classes listed on this course list that you have to take some of, right? You have to take, from category 3, you have to take 2 classes from this list of, 40 classes or something. And there are a lot of rules against double dipping, right? If you take this class to fulfill requirement 2, you can't take it for requirement 1. And there's a lot of interdependent stuff. If you take class A, then you have to take course B, things like that. So Nick and I have been thinking about this a lot and started to try to draw our own course maps, like those engineering ones, for other departments. So we did this for Cal State Fullerton and Econ, and this is like version 55, which is not that impressive as it is, right? But it's like super complicated when you start getting into more of the choice, right? Take one of these 3 classes, and then it's interdependent after there. And I think this, so what we're going to be talking today about is what are the effects of this kind of complexity, right? Like, how do we think about this complexity, and what does it affect for students? And this gets down to some really interesting philosophical questions, right? So departments are balancing simplicity with complexity and kind of freedom against real structure. And this comes down to some really important conversations that departments have, right? What do we want? What are the core pieces of knowledge that we want all of our graduates to know, right? And then how much fracturization do we want? Do we want students to be able to come out with this kind of wide range of skills, or do we really think that there's some core knowledge that our graduates need to have? And straight up freedom is super simple, right? If there are 150 classes and I say take 12 of them, take any 12 you want, that's really simple to figure out how to graduate. Straight structure is also super simple. If there are 12 classes and you need to take all of them to graduate, that's very easy. But it's when we mix this structure and this freedom that the real complexity happens, and that's where I think it's most difficult for students. And now this is like more interesting now that I am in a department where I sit on in the group that makes the curricular decisions for our undergrads. And I'm in those meetings, I come away and people are like, well, some faction thinks they need to know this, and some other faction argues for something else. And you can see how to make peace within these departments where everyone is autonomous and thinks that they are self-employed and can make all the decisions. We end up with really a lot of complexity that doesn't necessarily represent the best outcomes for students, but as a way of making peace within departments. And I think a lot of that comes out through these really complicated maps. So what Nick and I have been trying to figure out is, what is curricular complexity? What do we mean by that, and how can we measure it? So I think there are a bunch of different factors here, right? There are the number of requirements within a major, number of options overall and then within each requirement, and then all these kind of interdependent and choices in temporal dependency, right? So there are nested requirements. Within requirement 2, you have to take 3 classes that fulfill some other sub-requirement. There's this double dipping where one class could be counted for multiple requirements, but you can only use it once. And then there are cross-cutting requirements, like take these classes, but you need to fulfill a lab requirement, and that could be done in section A, B, C, or D, right? So there are a lot of different things to think about with complexity. And so we're trying to come up with a couple of different ways to measure curricular complexity within majors. So we have 3 different approaches, and I warned you at the beginning, we have data for approach 1, we have partial data for approach 2, and we have thoughts about data for approach 3. This is kind of this ongoing project. So the first thing that we've done is written these Boolean logic strings. And I have a picture of them, and if you can't read them, that's okay. So we're going through the 23 Cal States and the 9 UCs, and for each of 4 majors, econ, English, psychology, and biology, we are hand coding the requirements that you need to get a BA in that field. So we're doing that by first making a list of all the courses that are available, and then second, writing out these logic strings that are basically stata code that will allow us to figure out if a set of courses would lead to graduation, right? So you have something like you need to take a reading and writing class, a particular class. So if you take that one class that is coded with this particular tag, then you fulfilled that requirement. Then there are things like you need to take 6 required upper division courses, really simple. Those 6 are very clear, you take those. And then there are things where you have choices, right? 24 units of upper division requirements, only 2 can be in a certain level. So you need to write some kind of, you can only take the minimum of those classes in 6, whatever's lower, right? So it's like just kind of these simple strings, not that simple to write, I'll be honest. They are like incredibly cognitively demanding to write these, and I can only do it at like 7 a.m. because after that I'm totally, we had a team of graduate students doing this with us, and we found out that there was just like, it was too hard to be able to standardize across too many people. So Nick and I are doing it all by ourselves because it just seems like there's much more, we can have more control over the quality. So this is a relatively simple degree, right? This is Cal State LA in English. Here's UC Santa Barbara in biology. And you get to hear the things with like double dipping and stuff, right? Where you have to take some of these classes, but only some of them can come from certain requirements, and it can't be something that you've already taken, and blah, 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 right? And so this is more representative of what we're seeing across majors. And so the English language that we're coding here is something like select 2 courses from each of groups 1 through 4, select any 1 additional course from group 1 through 5, a total of 3 units of courses listed in applied psychology and community engagement can be taken toward fulfillment of the upper division elective, right? That's the kind of language that students are seeing, and this is the kind of coded pared down logic that we're using to code those. So for our first approach to measure complexity, what we're doing is just counting up the number of requirements and then counting the operators within each of those requirements, right? So this one has 5 different distinct requirements, and only one of them has multiple things within there, right? Only one of them has some added complexity, whereas the biology, right, there are 16 different or 14 different requirements, then each of them has, or many of them have these kind of added complexity within them. So that is our first approach to measuring the requirement, measuring complexity. What it doesn't get at is measuring this kind of overload of choice, right? When I showed you the biology requirement, there were 150 classes, right? These kinds of codes don't allow us to get at having to pick how to fulfill these requirements from multiple choices. So we're running simulations where we run we're running different through Stata. We're just kind of running random groups of classes through and seeing how many unique course paths could lead to graduation, right? So that allows us to say how many unique ways could a student move through this major and end up graduating. We were going to do kind of the inverse of that, where we take what's the probability that if you take a random draw or a kind of smart random draw of courses, you'll end up graduating, but it is too complex because we're ending up with millions of ways to graduate, and we actually couldn't even get it to run. So we had to do this kind of other way, which is just how many ways are there to graduate. That's our second measure of complexity. The third, which we're going to be doing hopefully next year, is we're coding up a little lab experiment where we have students, we give them major requirements and have students figure out how to graduate, right? And we're doing it in this, what it does not exist yet, a nice online survey. This is nice because it's not me just doing Qualtrics, which I do for all of my surveys. We're going to get someone to code up so we can really keep track of the mistakes that students make in trying to figure out how to graduate and how long it takes them. And so this will allow us to get a better sense at the complexity of a major, but also which components add the most of complexity. So we'll have 3 different measures of complexity. So we can look at how those measures move together if we see that they tell us the same thing, if they tell us different things. And then we're going to be looking at how does this vary across schools and across disciplines, right? So we can get some evidence of if certain disciplines tend to be more complex than others, and if some types of schools or schools are more complex. So this is the simplest, cutest little regression we're going to see probably all day today. Right, some measure of complexity as a function of a vector of discipline, fixed effects, and school fixed effects, right? And so just looking at the coefficients, they're going to give us some indication. So far what we've seen is that biology is by far the most complicated, econ is by far the most simple, which could reflect some ideas about how common knowledge is within those. English has a ton of requirements, but they're incredibly simple to fulfill, and psych is all over the place. Psych sometimes falls really close to bio and sometimes is much closer to econ. So that's the kind of preview of what we're seeing. None of this really tells us why we should care about any of this, other than that it's incredibly intellectually engaging and I enjoy it. But why do we care if majors are complex or not, right? So the next steps or current steps are we're looking at what are the effects of curricular complexity, right? Why do we care if the major requirements within a given major are very hard to figure out? So we're going to look at 2 different things. One, does this affect time to degree or even probability of graduating for students? And 2, does it affect the majors that students sort into, right? Do students make their decisions in any way based on the degree requirements? Part of why I started this project is because I was talking to a student of mine, a transfer student from Irvine Valley College who's at UC Irvine now, and she was in my office for office hours, and she said, I'm an education major, and I was gonna be a Spanish major too, but I can't figure out what classes I need to take, so I'm just not gonna do it. And I was just starting this project. I was like, Monica, you're kidding me. You can't figure out what classes to take? And she's like, no, look at it. You're not gonna be able to figure it out either. Went online, I couldn't figure it out, and the counselors didn't have, she's like, I can't meet with a counselor for 6 weeks. And so that kind of started me thinking, this really is affecting N of 1, but N of interesting 1, right? That this might be affecting students' behaviors. So we don't have much evidence on number one, right? Is there any effect of this on time to degree or probability of graduating? We do have good theory to believe that it might be, right? So from behavioral economics and psych, there's a ton of really interesting work about how choice architectures and individual decisions affect people's behavior, right? So we see that in related fields, but not in this particular environment, that it can lead to procrastination, suboptimal choices, or opting out of making a choice if a decision is too hard. We have good evidence that students graduate with many more credits than they need, which is not evidence that it's because they're taking wrong classes. It could be because they're dabbling or trying out different things, but potentially evidence that that's because they don't know which classes will count. And a lot of interview and focus group data where students say things like, I don't know which classes of these will count for graduation. I feel like I've made a lot of wrong choices in deciding on what to take, and expressing a lot of frustration about how hard it is to figure out what to take. So there's relatively good indirect evidence that this might lead, that simplifications in course requirements might lead to better outcomes for students. But it's hard to measure because often when schools are making changing course requirements, it happens across an entire school. So an entire school will go to a more simplified model, which really makes it hard to have any kind of counterfactual about what would have happened. But there's one piece of evidence from California. It was part of a much larger policy change, but one effect of the policy change was that within the California community colleges, some majors got a lot simpler. It went from having many choices to having basically no choices. And we see students graduating with 4 fewer units on average and taking 1 term less to graduate. So some evidence that this kind of simplification might affect student outcomes. So coming down the pike, we're hoping to leverage unique curricular changes within departments and then using a triple diff, comparing departments within the school over time to the same departments within a different school over time to look at student level outcomes. And then that lab experiment that I talked about where we can manipulate particular kinds of complexity to see if certain kinds are harder for students and lead students to make more mistakes. This is all in the context, I should have said earlier that there's a major movement across community colleges to make course plans much simpler. It's called the Guided Pathways, and it's rolling out across 20 community colleges in California over the next couple of years and about 100 across the entire country. And so people are really big on this. People think that this is making course plans much simpler is going to lead to better outcomes for students. But one thing that people haven't asked a lot about is if students have options and they see a choice between having a kind of usual course plan with a lot of options versus one of these very simple course plans, well, that we all think we like choice, right? Like we think that choice is a good thing, most of us as humans. Will that lead students to opt into the majors that have more course choices? No one has looked at if students have preferences for simplicity or complexity within major requirements. So we did 2 experiments where we asked students just that. We give them hypothetical course lists for majors and say, please express a preference. Would you rather choose major A or major B? And we ask about 3 different, we manipulate 3 different features. We manipulate if the courses are grouped together, so if there are those kind of requirement A, B, and C versus just here are the upper division courses. We manipulate if there are cross-cutting requirements, like you have to fulfill a lab requirement, and it can come from any of these options. And then we manipulate how many of choices are available for students by making the course list shorter or longer. So we did this for, we had about 2,000 students and 50 course sections at UCI and Cal State Fullerton. 50 course sections because course instructors wouldn't let me come to their big lecture hall, but they would let me go to the discussion section. So I was like, I've been in every building on UCI's campus, and I have didn't know the campus well, but I know it relatively well now. Going to 20 students at a time, right? Very inefficient way to get data, but when you really want data, you're willing to go. Relatively evenly split across grades, freshman through senior, represents kind of colleges in general, a little bit more female. And average self-reported GPA was about 3.1. So in the first experiment, what we did was gave students 2 out of the 4 of these, right? So we had each of the 4 disciplines, bio, psych, English, and econ, and they had to choose between 2 bio majors or 2 econ majors, and they were randomly selected to be 2 of the 4 of these. So no groups, right? So the upper division courses here are grouped into 3 different requirement sections. This is just one group. And then we had this departmental requirement, which it says courses with an asterisk fulfill the departmental requirement, and you have to take 2 of them. So we randomly assign students to 2 of these, and we say, which one do you prefer? And then like super simple, right, just OLS with a bunch of fixed effects where it's just which ones did they see. And what we find is students have no preference for groups or no groups. They don't mind when classes are grouped together, which is limiting their choice, right? That is limiting the ways that they can graduate and forcing them to take classes from different areas. They have no preference between groups and no groups, but they do have a preference for none of this departmental requirement, the star where it says you have to take 2 classes that fulfill this departmental requirement. So then the text for the departmental requirement was a little bit dumb. It said like, this is a departmental requirement, and like, that doesn't mean anything to students. So we did it again, changing the text to be either lab or writing requirement. So we said, this is a lab requirement, you have to fulfill the lab requirement or the writing requirement. And then the other thing that we changed was we were giving students either short lists or long lists, right? So we randomly assigned them to have more or fewer choices, and we were randomly leaving off classes from the short list to make sure it wasn't that there was like some super exciting class that students weren't seeing. And here we found really clear evidence that students have a strong preference for longer course lists. They want more options, like really strong preference. And here it's harder to see because they're not right next to each other, but there's no preference for or against stars. Different sample of students, so I can't say anything definitively, but it seems like when you give them that kind of information, students are more willing to go along with it if they know what the requirement is. Last thing we looked at was we gave students some text. So students were also randomly assigned if we told them why one list was shorter than the other. So the text read, the long list was said to represent all of the classes that have been popular with students over the past 5 years, whereas the short list said these are the core concepts of the discipline as identified by the department's faculty. So then we randomly assigned students to either see that explanation or not to see if that mediated this preference for long. And we found this is the kind of coefficient of interest, this interaction between having the explanation and long, and we see that that does reduce student preferences for long, having more options, right? So far what we found is that we have evidence, so I can't tell you any numbers or anything specific, that there's significant complexity within major requirements, that we don't have really good ways of talking about it or measuring it. We see it varies a little bit by discipline, but hopefully we can come up with ways to actually quantify this in a way that makes sense to compare across disciplines. Evidence to think that it might affect student outcomes, we'll hopefully be measuring that, and pretty good evidence from these experiments that students want choice, but they don't mind some guidance in that choice if they understand why they have it. So this, I think, is where we're kind of headed with this, is giving departments advice about how to structure these requirements, and we seem to find that students are willing to be guided towards choices, but they don't like this kind of reduction of choice without a lot of explanation. So that is where we stand. Thank you guys very much.